Hello, everyone. Welcome to all of you. So, what we are going to discuss today? We are going to discuss today about effects of temperature on resistance and its resistivity. Okay, effects of temperature on resistance and resistivity. So, what is resistance? All the appliances which we are using at our homes, like bulb, inverter, TV, fan, all are what are kind of resistance, which opposes the amount of electricity, opposes the current, you can say, opposes the current. Okay, and resistivity is the characteristics of that. Okay, resistivity is the characteristics of any substance. Like if you will consider the sweet and the sweetness, then the amount of sweet and sweet is a resistance, and sweetness is the resistivity. So from the 10th standard, we must have studied about it in Ohm's law. You remember now Ohm's law? So what we have studied in Ohm's law? We have studied in Ohm's law, V is equal to IR. Like what? Voltage is always directly proportional to current, right? And when we remove this proportionality constant, then we are getting a constant, that is R. So R is constant over here. Okay, that only. Remember? So from here only, we got the formula V is equal to IR. So from V is equal to IR, we can say R is equal to V upon I also. So resistance is the ratio of voltage and current, right? After that, we have studied about the factors affecting resistance. Okay, factors affecting resistance is what? On what factors the resistance depends. So resistance depends on the length of a conductor. Means resistance is directly proportional to length. Resistance is inversely proportional to area of cross section, which is perpendicular to the direction of the current. Area of cross section which is perpendicular to the direction of current. And when we'll combine both of these, then we are getting R is directly proportional to length upon area of cross section. Remember now? So now when we'll remove this proportionality constant, then what we are getting? Then we are getting R is equal to rho L upon A, where rho is what? Resistivity, right? Resistivity. Okay, so that much we have discussed from the 10th standard. Now here we have studied about the formula of resistance in the previous videos also. So what it can be? So R is equal to ML upon NE squared tau and A, right? Okay. So just now we have wrote one formula na, R is equal to rho L upon A. If we'll compare both of this, then what we'll get? Rho is equal to M upon NE squared tau. Okay. This only we will get now. The formula of resistivity, it will be, okay. So here, this is constant. Why resistivity is constant? See, now we'll get the components over here. So what is M? M is the mass of electron. N is number of free electrons per unit volume. Number of free electrons per unit volume, right? E is what? You must have aware about it. Charge of electron, right? If not, then not to worry. We are here to discuss about it. Now what is tau? What is tau? Average relaxation time. Average relaxation time. Average relaxation time. Now, what is this average relaxation time? What it could be? See, if this is a conductor, this yellow color is very light, right? If this is a conductor and electrons are here inside this conductor, and when we are doing any variations or when we are applying a potential difference across it, okay, so what will happen? these electrons starts moving. Electrons will move from negative to positive direction. This is the movement of the electrons. But what will be the direction of the current? The direction of the current will be from positive terminal to the negative terminal, right? This will be the direction of the current. So when the current moves, we can say when these electrons are getting potential difference, are getting energy, so they starts vibrating. So what will happen? They'll collide to each other. This electron will collide to this. So in between the collision, they'll get relaxed also, right? They'll get a relaxation time. For few seconds, they'll pause now. So that pause is known as relaxation time. Okay. So we discussed about the resistance and resistivity. Now we are going to discuss about its effect, like temperature effect on this. Okay, so we know like when we'll give so much potential difference, then there will be the variations in the temperature also, right? With the current, the temperature will also increase, right? So first of all, we'll consider about the conductors. The conductors. What are the conductors? Copper, iron, these all are the conductors, right? So as we know, what is the formula of resistivity? Resistivity is equal to m upon ne squared rho. And resistance is also depends on the formula of resistivity only. R is equal to ml upon ne squared tau A. So whenever the temperature will increase, so the electrons, the collision of electrons will also increase. Now you can check over here. Whenever the temperature, when the current will increase, the temperature will increase and the number of collision will also increase. When the number of collision will increase, then whatever the relax the electrons are doing in between, like as whenever we are doing the work, so we are taking 1 or 2 minutes nap. That is so much relaxing also. 5 minutes I am also taking sometimes. Now, so this relaxation time will decrease, right? For the conductors, number of electrons, they all will be constant and all, like they'll not be so much effective. So the relaxation time will decrease. So as resistivity is inversely proportional to the relaxation time, you can get from here only. Okay, you can get from here only. So when the relaxation time will decrease, so resistivity will increase. Got it? When the relaxation time will decrease, then resistivity will increase. And when the resistivity will increase, as we know, resistance is directly proportional to resistivity. Okay. So directly proportional to resistivity, then if resistivity will increase, then resistance will also increase. So what will be the graph between time and resistance? Or you can say resistivity also like a graph. Okay, like a graph. This will be the graph. So when the when for the conductor, when temperature increases, then relaxation time will decrease. When relaxation time will increase, then like this also resistivity will also increase. Here not will be effect of ionization of electrons, like number of electrons that will not effective so much. Okay, this will increase also. Now, if this will also increase, then also resistivity will decrease only. Okay, this will also increase, then also number of electrons will increase, then also the resistivity will decrease only, because this is inversely proportional to that. Now we are moving on semiconductors. For semiconductors, what will be happen? Semiconductors, you can say like silicon, germanium. Okay, these are these are all the semiconductors, right? Now, if temperature will increase, then what will happen? With the increase in the temperature, the relaxation time will decrease. Same for it. So what should be happen there? If relaxation time is decreasing, then resistance will increase. This kind of things also should be there, na? Resistance and resistivity both should increase, right? But what will happen? For semiconductors, this is negligible. Why? Because number of electrons will increase more and more and more. So as we know, resistivity is inversely proportional to number of electrons also, inversely proportional to number of electrons also. That is why when this will increase and increase more, then resistivity will decrease. Okay, so what will be the graph over here between resistance and temperature? Sorry, between the resistance and temperature, resistance or resistivity, it will be like this. With the increase in the temperature, the resistance or resistivity will decrease. Okay, it will decrease. Now for alloy, what will be happen? There will not any effect. Not any effect. Why there will not be any effect? Because alloy are not natural, you can say, not natural. Okay, these are not natural, you can say. That is why it will happen. Okay, that is man-made devices, you can say. Got it? Man-made things. So here, there, no, not anything will be constant. So what will be the graph between these? Like they'll be constant. So temperature, with the temperature, the resistance or resistivity, it will be constant only. You can make like straight graph also, or else sometimes it is given in the books like little bit change, very little change. That is negligible. Okay. Thanks for watching.